Every student on my team ate 3 slices of pizza. If one team member were absent, each of the other could have eaten 4 slices with no leftover pizza either time. How many students are on my team? Well, the total, let's say, is 3n. One team member we eventually is going to be absent, but initially that would be the total. So if n is the number of team members, 3 slices per each, so 3n. Now they're giving another scenario and saying that t can also equal, if you take one member out, so it'd be n minus 1, and then each of them eats 4 slices. So t is also that. So therefore you set these two equal to each other, since t is equal to 3n and t is also equal to 4n minus 1. So 3n is equal to 4n minus 4. So therefore 4 is equal to n. And that is the answer. 4 is the number of students on the team. On the very day that the Hill twins turned 90, a friend of theirs told them, "My age is half the square root of the product of your ages plus half the product of the square root of your ages. Write -1 if their friend was younger than the Hills, write 1 if their friend was older than the Hills, and write 0 if their friend was as old as the Hills." Okay, so we have to try to figure out the math. The age is half the square root of the product of your ages. So they're twins, so, and they're both 90, so the product of their ages would be 90 times 90. Half the square root, so then take the square root and then take half of it. Okay. Plus half of the product of the square roots of your ages. Half, okay, of the product of the square roots of the ages. So 90 times root 90 times root 90. So I believe that is the math. You just have to interpret the sentence into, mathematics. So let's see what this does. So this would be 90 over 2, which is 45. And this would be root 90 times root 90 is 90, so 90 over 2, which is 45, and therefore a is 90. So that means this person's age is also 90. So let's see, -1 if they were younger, 1 if they were older, and 0 if they were as old. So I guess the 0 is what we have to put as the answer to this question. If x squared plus 2x is 44, what is the value of x to the 4th plus 4x cubed plus 4x squared plus 66? All right, so we got to do a little bit of algebra here. X to the 4th plus 4x cubed plus 4x squared plus 66. Okay, so I think we can factor out an x squared, and that would be x squared plus 4x plus 4. Okay, and then plus the 66. I don't see how that helps. Let's try a different approach. Let's start with this guy. X squared plus 2x is 44. And eventually we have to get that. So we have to get some power of 4. So what if I squared it? Both sides probably definitely would give me a power of 4. 44 times 44. So I basically just squared both sides. And let's see when I expand what I get. So this looks like 2x to the power of 3 plus 2x to the power of 3 plus 4x squared. Is this 44 times 44? Okay, this is starting to look like this guy up there. So this is x to the power of 4 plus 4x to the power of 3 plus 4x squared is equal to 44 squared. Okay, so all I have to do is just add that 66 and I've got it. So x to the power of 4 plus 4x to the power of 3 plus 4x squared plus 66 is equal to 44 squared plus 66, correct? So that's it. 44 squared plus 66 would be the answer. That is equal to 2002. If A, B, and C are real, and if absolute value of A is less than or equal to 1, absolute value of B minus 1 is less than or equal to 10, and absolute value of A minus C is less than or equal to 10, what is the largest possible value of absolute value of A, B minus C? All right, so A absolute value is less than or equal to 1. B absolute value, B minus 1, I should say, is less than 10. And then we have this A minus C absolute value is less than 10, less than or equal to. So we are trying to maximize this guy. So maximize. Now to maximize that, we would have to maximize this guy and minimize that. Minimize C. Okay. Well, what is the maximum value of A? Well, I believe that would be A equals 1. What is the maximum value of B? Well, if B minus 1 is less than or equal to 10, then B would be less than or equal to 11. So the maximum value of B would be B equals 11. And then now we want the minimum value of C. And what do we have here? We have A minus C. So we're going to use this 1. So 1 minus C, less than or equal to 10. And therefore, 1 minus 10 minus 9. And C would be greater than or equal to that. So the minimum value would be C equals minus 9. And that's, I think, the simplest way of doing it, just by dropping the absolute values. So therefore, we take 1 for the value of A, for this guy, 11 for the value of B, and then subtract from it the negative 9. And then let's see what we get. So we get 11 plus 9, and that's 20. So 20 is the answer to that question. What is the ordered triple of positive integers ABC with C as small as possible that satisfies A to the power of B is 2 to the power of 2C. A is greater than 4, and A plus B is 4 plus C. Okay, well, A to the power of B is equal to, according to their question, 2 to the power of 2C. So A obviously is some power of 2. So A is a power of 2. Okay? So they're saying A is greater than 4. So what are the powers of 2 greater than 4? Well, 4, but that's not greater than 4. We have to use either 8 or 16 or 32 and so on, right? So something. So let's try. Let's try A equals 8 and see if it works. If it doesn't, we'll move on to A equals 16 and so on. So if A equals 8, then that means we have well, first with that one, we'd have A plus B is equal to 4 plus C, right? So if A is 8, it would be 8 plus B is equal to 4 plus C. So therefore, we have C is equal to 4 plus B. And then this equation, therefore, becomes 8 to the power of B is equal to 2 to the power of 2 times C, so that would be 8 plus 2B. Correct? And then 8 is 2 to the power of 3, so that would become 2 to the power of 3 to the B, and then that would basically be 2 to the power of 3B is equal to 2 to the power of 8 plus 3B. And then since the bases are the same, the exponents are the same, so that basically means that 3B is equal to 8 plus, oh, hold on. Yeah, that's right. So therefore, B would be equal to 8. Okay, so A is 8, B is 8, and we just have to find C. Well, C is equal to 4 plus B, so that equals 4 plus 8, so that's 12. So there we go. We got it. The ordered triple ABC would be 8, 8, and 12. An equilateral triangle sits atop a square of area 64. A circle passes through the vertices not shared by the square and the triangle. As shown, what is the area of the circle? So let's draw this a little bit bigger, and then I'll label it as best I can. So first we got this equilateral triangle. That sits like that, and then we've got the square. Oh boy, that's not drawn to scale, but that's okay, you guys understand. Okay, so now let's now label it. The center, let's think about this. Do they give us anything? The area is 64, so that means the size of the sides are 8. Okay, so 8, 8, 8, I got it. And then do they tell us anything else? It's an equilateral triangle, so that means that if this side of the square is 8, then those are also 8s, since it's equilateral. Okay, a circle passes through the vertices not shared by the square and the triangle. What is the area of the circle? Okay, so that's limited information. So let's draw the center of that circle, and then let's draw lines. So first let's draw the line that goes all the way to the top to bottom like that. Yeah. And then let's draw a line from the center of the circle to the vertices. And I think that is all we can do. And let's label it. So that from the center to the vertice, that would be R. That's R. And this little space, this little distance, I will call X. So therefore, from here to here, that looks like it will be 8 minus X, right? And then this distance from here to here is 4 because that's half of 8. There's a side length is 8. And then similarly, that's 4. And then this distance would be R minus X. R minus X. So we've got, I'm going to draw them again because I want them to be clear. These triangles. The first triangle up top, it's a right triangle, and this is R minus X. This is 4, and this is 8. And then this one is 4R and 8 minus X. Okay? All right. So now, obviously, with those two triangles, we can use Pythagoras to get relationships. So from the first one, we would get, let's see here, 4 squared plus R minus X squared would be 8 squared. And then from the second one, you get 4 squared plus 8 minus X squared would be R squared. Okay, and I think from there, we kind of move forward here. Now, there's a couple of ways. I think since we have two variables and two equations, we could go down that route. But it'd be a little bit complicated. I think I will, because there's squares involved, I think I will use the properties of this triangle because the fact that it's equilateral helps us. Why? Because it helps us with the angles. If it's equilateral, then that means that's 60 degrees, that's 60 degrees, and so on. So in this triangle, this is 60, and this is 30. So that's a 30, 60, 90 triangle, and the ratio of the sides of a 30, 60, 90 triangle are 2, 1, and root 3, the ratio of the sides. So that tells me that R minus X over, say, 4 would be the equivalent of root 3 over 1. So that means that R minus X would be 4 root 3, and therefore R would be equal to 4 root 3 plus X. Got it? So then that will help because then we can substitute that in there, and that would be a little bit nicer than trying to deal with a bunch of squares. So 4 root 3 plus X. And there we go. Now we have everything in terms of one variable, and then we can solve this. So we can solve for X. And then eventually, what do they want? The area of the circle. So the area of the circle would be obviously pi r squared. Okay, so once we get X, we can then get R because that's the relationship between X and R. And then we can, of course, just sub it into here. Okay, so we got a bunch of algebra here. Okay, no problem. Let's do the algebra. So we got 16 plus 64 minus 16x plus x squared, and then this will be 48 plus 8 root 3x plus x squared. X squareds go, that's very good. And we're just left with 80 minus 16x, and that's 48 plus 8 root 3x, and that's going to be 32 is equal to 8 root 3x plus 16x, and therefore x is equal to 32 over 8 root 3 plus 16. So not a very pretty number, but it is what it is. So then now we can substitute this guy here to figure out r. R is 4 root 3 plus this 32 over 8 root 3 plus 16. And well, calculators are allowed, so you got a couple choices. You can convert this to, because we eventually just have to figure out pi r squared. Now you have a choice. You can convert this to sort of a number and then plug it in here. That'd probably be a little quicker than rationalizing the denominator and getting all that stuff, right? So let's do that. Since calculators are allowed, let's use the calculator. When you do calculate this number, interestingly, is 8. Exactly 8. So pi r squared, therefore, would be pi times 8 squared, which is 64 pi.